So one reason to be interested in the phase change from a liquid to a gas is vaporization. Vaporization is what's actually happening when you are consuming THC or other cannabinoids in cannabis. And the heat from either smoking it or from using a vaporizer is going to take the kind of sticky crystalline bits where a lot of the cannabinoid compounds are found and convert them into a gas so they can be ingested and then people will then experience the psychotropic medicinal effects of the plant. That heating process also initiates a chemical reaction that occurs that converts THCA into THC, but we will talk about that when we talk about chemical reactions. Right now, I just going to think about the difference between vaping and combusting the cannabis plant for transferring cannabinoid compounds from the plant into a body. So let's start with the punchline, which is vaporization is going to be a phase change from liquid or to a gas, or it could be sublimation, right? If we had a solid and it was going to the gas. And then combustion is going to be an actual chemical reaction. So we've been talking about phase changes. Vaporization is the same as evaporation, is the same as boiling. They're all words that are describing this process of a liquid converting into a new state of matter, gas. But in that conversion from liquid to gas, the molecule's shape and how the atoms are bonded together doesn't change. If those bonds change, that's a chemical reaction that's occurring. And so this is going to be a physical change where that molecular structure stays the same. Let's look at this for THC. So again, this is the line structure for THC rather than the full Lewis dot structure. But this compound is going to vaporize at 315 degrees Fahrenheit. If you think in Celsius, it's 157 degrees Celsius. So remember, water boils at 100 degrees Celsius. And so this is a higher temperature than that. And even though water has two hydrogen bonding interactions, it's really polar, and this molecule is less so, it's very large. And the just molecular weight of a molecule can impact the temperature at which it would undergo a phase transition. So THC vaporizes at 315 Fahrenheit or 157 degrees Celsius. Let's look at what happens with combustion. So combustion is a chemical reaction. It's a reaction between some compound, typically with carbon and hydrogen bonds, and oxygen. It's actually a redox reaction or combustion reaction. And it produces gaseous materials like carbon dioxide, sometimes carbon monoxide or carbon solid, and water vapor. If there's other compounds in there, you might also produce some NO2 or N2 and things like that. But if you have something like propane right here, so CH3H8 is propane, and you have oxygen around and ignite it, you will start a fire. This is how I cook when I barbecue, right? Taste the meat, not the heat, right? And that's going to produce as a product for that chemical reactions. It breaks the bonds in the propane and forms new bonds with oxygen. So the carbon bonds with the oxygen, the hydrogen bonds with oxygen, you form carbon dioxide and water. So this is a chemical change rather than a physical change. So thinking about a dried cannabis bud, which I'm gonna I don't have a chemical formula for the whole plant, right? There's lots of things in it, and a lot of them have carbon, and a lot of them have hydrogen, and there's some other stuff too. So this is why I said it's like you take this plant material. You can also think of like dried leaves in the same way, and around oxygen, you ignite it. You will break the bonds that exist within the plant's structure, produce carbon dioxide and water and some other stuff. Like you'll produce that carbon soot, that kind of ashy stuff. And there'll be some other gases produced too, depending on the chemical structure of everything inside that plant material. So what temperature does this occur at? Well, so I mean, for dried cannabis, it's going to occur. We can have combustion take place at about 451 degrees Fahrenheit or 232 Celsius at the low end. Dried leaves, like if you just took like a handful of dried leaves outside, they typically combust on their own around 575 degrees. And so this is a little bit lower than that. But so that is at a higher temperature than just the vaporization of THC. So think about what is happening when we are combusting cannabis, when we are smoking it as a rolled joint or as like bong hit or something like that, where you're applying a flame to a dried plant material and it is creating an ember, right? And you see the smoke come up. Well, so a lighter is going to produce a flame around 600 degrees Fahrenheit or 315 degrees Celsius. So that temperature is well above that combustion point of the dried cannabis flower, and it's well above the vaporization point. And so when that flame comes in contact, it is the part that is actually on fire is undergoing combustion. And so it's breaking down the plant material and converting it into other molecules that are not THC, like, right? It's breaking down that THC molecule if it is part of the combustion process into carbon dioxide and water. And that is not what has a medicinal property for the smoker at all, right? And so what's happening when smoking, so like how do you, like, you could still smoke and still access the medical benefits, right? Well, so think about it, imagine a joint and you ignite one end and it is a combustion reaction at the end, but it is heating up the air around it. And that air is then drawn through the plant material. And that process of the hot air being drawn through the plant material that's not on fire is going to have the cannabinoids vaporize, right? And so they'll vaporize rather than combust as they're pulled through. And then that's how you get the medical benefits of it, or the psychotropic benefits of the plant. Whereas if you are using a vaporizer set to a specific temperature below the combustion point, then when it's heated, the plant material doesn't actually burn, and instead it stays below that combustion point. It just vaporizes the cannabinoid compounds on the plant into a smoke or a gas, right? A gas that can then be consumed and ingested. And that gas has those whole molecules present within it rather than them having broken apart and the bonds being broken and reformed into new molecules. So I looked into this because I then got curious. I was like, well, then how much THC really enters into the body when you're smoking it versus when it's being vaporized? And some studies around 1982, another one in 1990, came up with somewhat similar results that about using a smoking through a joint specifically, about 20% to 37% of the THC present in the plant was then found in the bloodstream of the user, right? So about 20 to 37% of the THC goes from the flower through smoking into your bloodstream. Whereas with vaping, that number goes up to about 50%. These are like, it's very rounded, right? Like it's not exact. So quite a bit more. Here's another interesting one that I did right here, but also if the smoke from and the vapor from the combustion reaction is drawn through a sample of flower through water, so using a bong, then we actually decrease the THC available to the user by down to like 10 to 15% is making it into the bloodstream, which is super interesting. And so the combustion reaction itself is losing a lot of the cannabinoid compounds just to the atmosphere, right? So there's less efficient conversion of compounds in the plant into the bloodstream of the person consuming it.